This problem starts out by giving you the mass of the rocket, the initial velocity, I'll call that v number 1, and it tells you what the increment of time here is in your graph. So I'm going to call that delta t. That's this increment of time. It's different for different people. And so in part A, they ask you to find the impulse. Well, we know that the impulse is the area underneath the force versus time graph. So this area right here. So for this graph, that's going to be 1/2 the base times the height of that triangle, because that's how you find the area of a triangle. So that's going to be 1/2. The base is going to be 1, 2, 3 times whatever your time increment is. So that's 3 delta t's. And then the height is 1,000. So you multiply that and you get the impulse. In part B, they ask you at what time does a rocket reach its maximum speed? Well, obviously, if it's going to be pushed forward this whole time, then it's not going to get to its maximum speed until you're done pushing it. So right here, that's when the maximum speed is going to be attained. So the time then is going to be 3 time increments, whatever your time increment is. And then the last question is, what is the maximum speed? Well, here's where we're going to use the impulse momentum theorem. Impulse momentum theorem says that the impulse is not only the area under the curve, but that impulse is also equal to the change in momentum, which in this case is mass times the change in velocity, also known as mass as v number 2 minus v number 1. So we know the impulse from before. We have that number over here. So we know this impulse, we know the mass, and we know v1, so we should be able to find v2.